Installing copper mesh in the walls of an electromagnetic compatibility or EMC lab requires careful planning and execution. It's crucial to consult with an EMC engineer to determine the specific requirements for your installation. The engineer will specify the mesh size, type, and grounding system needed for effective shielding. It is also recommended to contact companies that specialize in electromagnetic interference or EMI and radio frequency interference or RFI shielding solutions. These companies have experience in installing copper mesh and can provide recommendations tailored to the project's unique demands. Industry standards provide valuable guidance. Refer to relevant standards such as the Institute of Electrical and Electronics Engineers Standard 299.2006, Recommended Practice for EMI Shielding Enclosures, for detailed information on copper mesh installation. Obtain technical data sheets from copper mesh manufacturers. These sheets contain specifications, installation instructions, and grounding requirements that are essential for a successful project. Now, let's discuss the electrical contractor's responsibilities in this installation. Grounding is paramount. The electrical contractor must install a proper grounding system for the copper mesh according to the EMC engineer's specifications. This typically involves connecting the mesh to ground rods or the building's existing electrical grounding system. Electrical continuity is also key. The contractor must ensure that the copper mesh maintains electrical continuity throughout the entire installation. This involves overlapping and bonding the mesh segments to prevent any gaps or high impedance points that could compromise the shielding effectiveness. Compliance verification is another crucial step. The electrical contractor needs to work closely with the EMC engineer to verify that the installed copper mesh meets the specified shielding requirements. This may involve conducting EMI testing or modeling to ensure the lab achieves the desired level of protection. The electrical contractor should provide maintenance instructions to the client, including guidance on how to inspect and clean the copper mesh regularly to ensure its long-term functionality. Here are some additional suggestions to consider. Firstly, using a corrosion-resistant copper mesh is recommended. This will prevent degradation over time, ensuring the shielding remains effective for years to come. Secondly, the copper mesh should be installed continuously around the entire perimeter of the EMC lab, including the walls, ceiling, and floor. Any gaps in the shielding can compromise its effectiveness. Thirdly, all openings, such as doors, windows, and ventilation ducts, should be shielded with conductive materials to maintain the integrity of the enclosure. Fourthly, it is beneficial to train the lab personnel on the importance of maintaining the integrity of the copper mesh and grounding system. This will help prevent accidental damage or modifications that could reduce the shielding effectiveness. Here's a more detailed look at the key areas we've discussed. The EMC engineer plays a pivotal role in determining the specific requirements for the copper mesh installation. They will analyze the electromagnetic environment of the lab, identify potential sources of interference, and specify the necessary shielding levels. This assessment will guide the selection of the appropriate copper mesh, its grounding configuration, and any additional shielding measures that may be required. Specialized installation companies bring expertise in EMI and RFI shielding. They have experience with various types of shielding materials and installation techniques, ensuring that the copper mesh is properly installed and integrated into the lab structure. These companies can also provide valuable insights into best practices for maintaining the shielding system. Industry standards like IEE Standard 299.2006 offer comprehensive guidelines for EMI shielding enclosures. These standards cover topics such as material selection, construction techniques, grounding methods, and testing procedures. By adhering to these standards, you can ensure that your copper mesh installation meets industry-recognized best practices. Manufacturer datasheets provide detailed information about the properties and performance of specific copper mesh product. These datasheets typically include information on shielding effectiveness, electrical conductivity, corrosion resistance, and installation recommendations. Carefully reviewing these datasheets will help you select the right copper mesh for your specific application. The grounding system is a critical component of the copper mesh installation. It provides a low impedance path for stray currents to flow to ground, preventing them from interfering with sensitive equipment inside the EMC lab. The grounding system should be designed and installed in accordance with relevant electrical codes and standards. Electrical continuity ensures that the copper mesh acts as a continuous shield, preventing electromagnetic waves from penetrating the enclosure. This requires careful overlapping and bonding of the mesh segments to minimize any gaps or high impedance points. Proper bonding techniques include soldering, welding, or using specialized conductive adhesives. Compliance verification is essential to ensure that the installed copper mesh meets the required shielding levels. This typically involves conducting EMI testing using calibrated test equipment. Test results are then compared to the specified shielding requirements to determine if the installation is compliant. Regular maintenance is crucial for preserving the long-term effectiveness of the copper mesh shielding. This includes inspecting the mesh for any signs of damage or corrosion, cleaning the mesh to remove any dirt or contaminants, and verifying the integrity of the grounding system. Corrosion-resistant copper mesh is recommended to prevent degradation over time, especially in environments with high humidity or exposure to corrosive chemicals. This type of mesh is typically treated with a protective coating that resists oxidation and other forms of corrosion. Continuous installation around the entire perimeter of the EMC lab is essential to create a complete electromagnetic barrier. This includes the walls, ceiling, and floor, as well as any openings such as doors, windows, and ventilation ducts. Shielding any openings with conductive materials is crucial to maintain the integrity of the enclosure. This can be achieved by using shielded doors and windows, as well as conductive gaskets and seals around any openings. Training lab personnel on the importance of maintaining the copper mesh and grounding system is vital for ensuring the long-term effectiveness of the shielding. This training should cover topics such as proper handling of equipment, avoiding physical damage to the mesh, and reporting any signs of damage or corrosion. In summary, installing copper mesh in an EMC lab is a complex project that requires careful planning, execution, and maintenance. By following these recommendations and guidelines, you can ensure that the installation provides effective EMI and RFI shielding, protecting sensitive equipment, and ensuring accurate test results. Remember to prioritize safety and consult with qualified professionals to ensure a successful outcome. The proper installation of copper mesh involves more than just physically attaching the material to the walls. It requires a deep understanding of electromagnetic theory, grounding principles, and construction techniques. Here's a more detailed breakdown of the key aspects. Firstly, understanding electromagnetic theory is key. A basic understanding of how electromagnetic waves propagate and interact with conductive materials is essential for designing an effective shielding system. This includes understanding concepts such as skin depth, impedance, and resonance. Secondly, grounding principles must be understood. A properly designed grounding system is critical for diverting unwanted currents away from sensitive equipment. This requires understanding concepts such as single-point grounding, equipotential bonding, and ground loops. Thirdly, construction techniques are important. The copper mesh must be installed in a way that ensures continuous electrical conductivity and minimizes gaps or discontinuities. This requires careful attention to detail and the use of appropriate bonding techniques. The choice of copper mesh material is also important. Copper is an excellent conductor of electricity and provides effective shielding against a wide range of electromagnetic frequencies. However, different types of copper mesh are available, each with its own unique properties and performance characteristics. Consider the following when selecting copper mesh. Firstly, mesh size must be decided. The size of the mesh openings affects the shielding effectiveness, with smaller openings providing better shielding at higher frequencies. Secondly, wire diameter needs to be determined. The diameter of the copper wire used in the mesh affects its conductivity and mechanical strength. Thirdly, weave pattern must be picked. The weave pattern affects the mesh's flexibility and ability to conform to irregular surfaces. Fourthly, coating needs to be considered. A coating can be applied to the copper mesh to improve its corrosion resistance and prevent oxidation. Proper bonding techniques are essential for ensuring electrical continuity between the copper mesh segments. Here are some common bonding techniques. Firstly, soldering can be used. Soldering involves using a molten metal alloy to join the copper mesh segments together. Secondly, welding is another possibility. Welding involves using heat to fuse the copper mesh segments together. Thirdly, conductive adhesives are an option. Conductive adhesives are specially formulated adhesives that provide electrical conductivity between the bonded surfaces. When installing copper mesh around openings such as doors and windows, it's important to use shielded doors and windows that are specifically designed to provide EMI shielding. These doors and windows typically incorporate conductive gaskets and seals that create a continuous electrical connection with the surrounding copper mesh. Ventilation ducts can also be a source of electromagnetic interference. To shield ventilation ducts, you can use conductive duct tape or wrap the ducts with copper foil. It's also important to ensure that any electrical wiring or equipment that passes through the copper mesh enclosure is properly shielded and grounded. This can be achieved by using shielded cables and connectors, as well as grounding all electrical equipment to the same grounding system as the copper mesh. Finally, remember that the effectiveness of the copper mesh shielding depends on the quality of the installation. Take your time, pay attention to detail, and follow all applicable codes and standards to ensure a successful outcome. The long-term performance of the copper mesh shielding can be affected by several factors, including corrosion, physical damage, and improper maintenance. Regular inspections and maintenance are essential for preserving the shielding's effectiveness. Here are some tips for maintaining copper mesh shielding. Firstly, inspect the mesh regularly for any signs of damage or corrosion. Secondly, clean the mesh to remove any dirt or contaminants. Thirdly, verify the integrity of the grounding system. Fourthly, repair any damage to the mesh promptly. Fifthly, replace any corroded sections of the mesh. By following these tips, you can help ensure that your copper mesh shielding provides years of reliable protection against electromagnetic interference. In addition to the technical aspects of copper mesh installation, it's also important to consider the safety aspects. Copper mesh is a conductive material, so it's important to avoid contact with live electrical circuits. Wear appropriate personal protective equipment, such as gloves and eye protection, when working with copper mesh. If you're not comfortable working with electrical equipment, it's best to hire a qualified electrician to perform the installation. Remember, safety should always be your top priority. Choosing the right type of copper mesh is vital for effective shielding. There are several factors to consider when making your selection. Here are some things to think about. Firstly, consider the frequency range of the electromagnetic interference you're trying to shield against. Different types of copper mesh offer different levels of shielding effectiveness at different frequencies. Secondly, think about the environmental conditions in which the copper mesh will be used. If the mesh will be exposed to moisture or corrosive chemicals, it's important to choose a corrosion-resistant material. Thirdly, keep in mind the mechanical requirements of the application. If the mesh needs to be flexible or conform to irregular surfaces, choose a mesh with a suitable weave pattern. Fourthly, factor in the cost. Copper mesh is available in a wide range of prices, so it's important to choose a material that fits your budget. By carefully considering these factors, you can choose the right type of copper mesh for your specific application. The process of grounding the copper mesh is critical for ensuring its effectiveness. A properly grounded copper mesh provides a low impedance path for unwanted currents to flow to ground, preventing them from interfering with sensitive equipment. Here are some tips for grounding copper mesh. Firstly, use a dedicated grounding conductor. The grounding conductor should be sized according to applicable electrical codes and standards. Secondly, connect the grounding conductor to a suitable ground point. The ground point should be a low impedance connection to earth, such as a ground rod or a building's grounding electrode system. Thirdly, ensure that all copper mesh segments are electrically connected to the grounding conductor. This can be achieved by soldering, welding, or using conductive adhesives. Fourthly, minimize the length of the grounding conductor. The shorter the grounding conductor, the lower the impedance. By following these tips, you can ensure that your copper mesh is properly grounded and provides effective EMI shielding. Maintaining the integrity of the copper mesh installation is crucial for long-term performance. Over time, the mesh can be damaged by physical abuse, corrosion, or improper maintenance. Here are some tips for maintaining the integrity of copper mesh installations. Firstly, avoid physical contact with the mesh. The mesh is delicate and can be easily damaged by sharp objects or excessive force. Secondly, protect the mesh from corrosion. If the mesh is exposed to moisture or corrosive chemicals, apply a protective coating. Thirdly, clean the mesh regularly to remove dirt and contaminants. Fourthly, inspect the mesh periodically for any signs of damage or corrosion. Fifthly, repair any damage to the mesh promptly. Sixthly, replace any corroded sections of the mesh. By following these tips, you can help ensure that your copper mesh installation provides years of reliable EMI shielding. The electrical contractor's role in copper mesh installation is vital for a successful project. They are responsible for ensuring that the mesh is properly grounded, that all electrical connections are secure, and that the installation meets all applicable codes and standards. Here are some key responsibilities of the electrical contractor. Firstly, installing the grounding system. The electrical contractor must install a grounding system that meets the requirements of the copper mesh installation. Secondly, connecting the copper mesh segments. The electrical contractor must ensure that all copper mesh segments are electrically connected to each other and to the grounding system. Thirdly, verifying the electrical continuity of the installation. The electrical contractor must verify that there are no breaks or discontinuities in the electrical path of the copper mesh. Fourthly, inspecting the installation for any potential hazards. The electrical contractor must inspect the installation for any potential hazards, such as exposed wiring or sharp edges. Fifthly, documenting the installation. The electrical contractor must document the installation, including the type of copper mesh used, the grounding system installed, and any other relevant information. By fulfilling these responsibilities, the electrical contractor can help ensure that the copper mesh installation provides effective EMI shielding and meets all applicable safety requirements. The electromagnetic compatibility, or EMC, lab environment demands meticulous attention to detail during copper mesh installation. It's not just about shielding, it's about creating a controlled electromagnetic environment where accurate testing and measurement can occur without interference. Firstly, the choice of materials matters. Selecting the correct grade and type of copper mesh is crucial. Factors like conductivity, corrosion resistance, and weave density all play a role in determining the effectiveness of the shielding. Secondly, surface preparation is key. Before installing the copper mesh, the walls and surfaces must be properly prepared. This may involve cleaning, smoothing, and applying a conductive adhesive to ensure proper contact and bonding. Thirdly, overlapping and sealing are essential. When joining sections of copper mesh, overlapping and sealing are necessary to maintain continuous shielding. Conductive tape or specialized adhesives can be used to create a tight seal and prevent electromagnetic leakage. Fourthly, grounding is paramount. Proper grounding is essential to dissipate electromagnetic energy and prevent it from interfering with sensitive equipment. A dedicated grounding system should be installed and connected to the copper mesh at multiple points. Fifthly, testing and verification are necessary. After the copper mesh is installed, it's important to test and verify its effectiveness. This may involve using specialized equipment to measure electromagnetic field strength and identify any areas of leakage. The integration of copper mesh with other building systems is also important. For example, if the EMC lab has ventilation ducts, these must be properly shielded to prevent electromagnetic interference from entering or leaving the lab. Similarly, any windows or doors must be designed with shielding in mind. The training of lab personnel is often overlooked, but it's essential for maintaining the integrity of the EMC lab. Lab personnel should be trained on the importance of avoiding physical contact with the copper mesh, as well as how to identify and report any signs of damage or corrosion. The long-term performance of the copper mesh shielding is affected by environmental factors such as humidity, temperature, and exposure to corrosive chemicals. Regular inspections and maintenance are necessary to ensure that the shielding continues to perform as intended. Repairs should be made promptly to address any damage or corrosion. It's crucial to consider the specific requirements of the EMC lab when designing and installing the copper mesh shielding. Factors such as the size and shape of the lab, the types of equipment being used, and the level of shielding required all play a role in determining the optimal shielding solution. In some cases, it may be necessary to combine copper mesh with other shielding materials such as metal panels or conductive coatings to achieve the desired level of performance. The installation of copper mesh in an EMC lab is a complex and challenging project. It requires careful planning, attention to detail, and a thorough understanding of electromagnetic theory. By following these guidelines and working with qualified professionals, you can ensure that your EMC lab provides a controlled electromagnetic environment for accurate testing and measurement.